Hello students, welcome back to my channel. So, continuous of the fifth chapter, electrostatic potential and capacitance. In that one, most important question, another two questions that are the combination of capacitor in series and parallel. Okay, combination of capacitors in series and parallel. In that one, first one we are taking. These two questions are separated questions, four marks questions. So first of all we are taking here combination of capacitor in series, first one. So in further question we are having diagram C. Let us consider we are taking here three capacitors. Let us consider we are taking here three capacitors. These three capacitors are connected in series. These three capacitors are connected in series. That's C1 capacitor C1 and C2 and C3. Okay, and now see here how can we write the statement for it. This is connected to the battery positive and negative terminal. See, how can we connect it to the here, how can we write the definition, how can we write the statement for it. See here, first plate, second plate, first plate, second plate, first plate, second plate. And now see here, second end of the first plate, second end of the first place is connected to the first plate of the second capacitor. Second capacitor. And second plate, second end of this, second plate of the second capacitor is connected to the first plate of the third capacitor. And second plate of the third capacitor is connected to the battery negative terminal, and first plate of the first capacitor is connected to the battery positive terminal. This is the statement of this combination of capacitor in series. Okay, and now see here, in this combination of capacitor in series, the charges are appeared. Each and every capacitor is same. So here, which one constant here? Charges are constant. So we can write here Q1 is equals to Q2 is equals to Q3 is equals to Q only. Okay, and now second one, the potential can be drawn on each and every capacitor is different. So here potential decreases how much serving, this one V1, here how much serving, this one V2, here how much, this one V3. So okay, this one V3. And now see here we can write here total potential difference, that is V is equals to V1 plus V2 plus V3. V1 plus V2 plus V3. And now see here, but we know that capacitor formula, but according to the definition of capacitor formula, see here, C is equals to Q by V. Everyone, we know this one. So from this formula we can write here V1 is equals to Q by C1 and V2 is equals to Q by C2, because of here Q is a constant, and V3 is equals to Q by C3. So these all values we have to substitute in that formula, then we will get here that implies V is equals to here V1 means nothing but that is Q by C1 plus V2 means nothing but that is Q by C2 plus V3 means nothing but that is a Q by C3. Then again here total potential difference, that is V is equals to Q by C, we can write is equals to, here take out the common here Q, you will get 1 by C1 plus 1 by C2 plus 1 by C3. So Q cancel. So we can write here 1 by CS here because of capacitors connected in series. So 1 by CS is equals to 1 by C1 plus 1 by C2 plus 1 by C3. This is for only 3 capacitors. Suppose it has here for n capacitors. For n capacitors. For n capacitors. N capacitor formula is 1 by CS is equals to 1 by C1 plus 1 by C2 plus 1 by C3 plus dash plus 1 by Cn. This is for n capacitors connected in series. Okay, this is the formula combination of capacitor in series. So this is a combination of capacitor in series. Same as it is, we have to find out here combination of capacitors in parallel. So next one, another one 4 mark question. This one also 4 mark and this one also 4 mark question. These two are separated questions. Okay, so now I am writing again combination combination of capacitor in parallel. Okay, this is the combination of capacitor in parallel. So now see here also we are going to take here. See, let us consider we are taking here three types of capacitor. Capacitor 1, capacitor 2, capacitor 3. We are taking here three types of capacitors. See here, let us consider we are taking here three types of capacitor. This is a capacitor C1, C2, C3. So each capacitor can be consist here two types of plates. Okay, plate 1, plate 2, plate 1, plate 2, plate 1, plate 2. And now see here, these two capacitors are connected to battery positive and negative terminal. I mean, these three capacitors are connected to battery positive and negative terminal, When the charges are appeared, when the current will be passing here, the charges it can be passing here different. See here, and now see here. Now first point, how can we connect it here? How can we write the statement for the combination of capacitors in parallel means first plate of all capacitor is connected to the battery positive terminal and the second plate of the all capacitor is connected to the battery negative terminal. This is a statement of this combination of capacitors in parallel. Okay, and now see here, when the charges are appeared and each and every capacitor is different. Q1 charge can be passing the capacitor C1 and Q2 charge can be passing on the C2 and Q3 charge can be passing on the C3. And now see here, when the potential difference can be dropped on each and every capacitor is same. So we can write here potential difference is same. So V1 is equals to V2 is equals to V3 is equals to V only. Also now see here, the charges are different. The total charge, that is Q, is equals to Q1 plus Q2 plus Q3. But we are having formula. What is that formula? The capacitor formula, that is C is equals to Q by V. From that formula we can write here Q is equals to CV, and if you want to write Q1, Q2, Q3, and now see here Q1 is equals to C1V and Q2 is equals to C2V and Q3 is equals to C3V. These all formulas you have to substitute in this formula only. See, that is therefore Q is equals to Q1 plus Q2 plus Q3. Then again Q means nothing but we can write here CV. CV is equals to C1V plus C2V plus C3V. So now here CV is equals to, take out the common here V, we will get here C1 plus C2 plus C3. So here VV cancel. So we'll get the formula easy. These are the parallel, so that's why we are writing here CP. CP is equals to C1 plus C2 plus C3. This is for only three capacitors. Suppose if you want here for n capacitors, we are having formula, that is CNP CP is equals to C1 plus C2 plus dash plus Cn. This is the formula for n capacitors. So I request you to once again see, you can check once again, that is a combination of capacitor in series and this is a combination of capacitor in parallel. These two questions are separated questions. This one also 4 mark question and this one also 4 mark question. Very, very important. Okay, I hope you all are understand this question. Once again you can check this one. I think you all are understand this one. Okay, I hope you got this, because of this is very easy. Okay, I request you to all members please like and share and subscribe my channel, because of whenever I will upload any videos, definitely it can become in front of you only. Okay? Thank you very much.